Oh, it's good. So we discussed this one, right? Drift velocity. So now we'll see here relation between all these three. Relation between current, current density, and drift velocity. Now, if I take one area from where like current will be flowing. So let's take one conductor. Okay, so this is like we are considering one something cylinder type thing. So it's area of cross section. It's like we can say A. Area of cross section is A. Then like if electric field is passing through it, E. All is this standard thing. So number of free electrons for that charge equals to n times of A, B, D, delta T, E. Now, how we got this? By I. I equals to, let's take small this. This is by volume. This is your volume. Number of free electrons and portion of the volume. And for one electron.
Charge of electron?
Sorry?
Like we should multiply it by charge of electron, E.
Yeah. So it is E, charge of electron. So delta Q equals to, or let's write directly for current. We need current, right? I equals to delta Q by delta T equals to T and T will get cancelled. So and E V V D A. That is your final form. So J equals to I by A. So A will get cancelled. So N E V D. Because J equals to I by A. By this we can go for Ohm's law also. This is an important one. Now, as we know, J equals to N E V D. So VD also we can write here from previous formula ET by M. And E tau by M. That's what we wrote before.
Yeah, sir.
here. This will become NE square E tau by m. So except E, remaining everything will consider as sigma E. J equals to sigma E, which is Ohm's law. Now sigma is the conductivity. Sigma equals to NE square tau by resistivity 1 by sigma. Rho equals to 1 by sigma means m equals to NE square tau. Now here sigma and rho, these are the functions. This is the function of material. This is a function of temperature. Okay, now what is a function you have studied in mathematics, right? First chapter function. In 12th standard, I think the first chapter is function. So I wrote here function of material and function of temperature. What does it mean? Tell me.
It is something that defines a relation or like
Yes.
relation between two different quantities, like of which are from two different groups, like a relation between two elements from two different groups.
Exactly. So I can write here f of sigma comma t, not t, sorry, rho. This is just for understanding. Next thing. Ohm's law. Like this is what another form. Now we have some conductor. Same conductor will take length L, area A, potential V. Same thing, whatever we did here. Length L, area A, potential V. So electric field E equals to V by L. And J equals to sigma E, that we know. So let's include everything here. This is L. Connected. So here, electron drift is on this direction. Electric field on this direction. Current also this direction. This is your V. Drift electron means motion of electron on this direction. So J equals to sigma E. J equals to I by A equals to sigma E. Now sigma I can write as 1 by rho. E I can write as V by L. So let's combine everything. It's capital V. So V equals to
AV
I,
by,
yeah,
okay,
I'm just doing from here. I into rho into L. I into rho into L by A. So
and
this,
one is resistance R.
exactly. So this will consume as R. This is the other way of making Ohm's law.
Yeah, and that's the definition, right? Potential
Yeah,
difference across a wire, like ends of the wire, is directly proportional to its current.
yeah. R equals to rho L by A or 1 by sigma, no, 1 L by sigma A. Either way. SI unit,
SI is ohms.
ohm or or
I don't remember the other.
from here I can say make unit volt per
Volt, volt per ampere.
exactly. And symbol below. Now slope of VI graph will give you V I slope equals to tan theta equals to R. Slope of VI will give you resistance. Okay, this resistance unit is ohm. Then what is conductance unit? Conductance is opposite of this one. That's right then.
How to pronounce? MHO, I guess.
Conductance is 1 by resistance.
Yeah,
Or
there's a unit, right? Ohm
ohm
inverse.
inverse.
Or they even call it this, right? MHO. I don't know
Mo
how to pronounce.
yeah,
Yeah.
you can pronounce whatever way you want. So basically, this law, Ohm's law, whatever we started with like assumption. Okay, so it is only fulfilled by conductors. It cannot be fulfilled by like semiconductors, insulators, or even solution also. Even solution also cannot fulfill this. Only conductor will fulfill because in that only resistance will be constant. So color coding, it's not for your CPSC or board exam, but
Yeah.
it's there for JEE exam. You are not for NEET exam.
Okay.
I guess you know already, right? Color coding,
No, sure, they didn't teach us.
not? Okay.
No, like,
Even it's easy only. Just one statement you remember, that's more than enough. Nothing. See, you'll learn in just 1 minute. It is B Roy. BB Roy goes to Bombay via gateway with gold and silver. So let's write. First B is your black. So what is mnemonics? BB Roy goes to Bombay via gateway with gold and silver. Can you remember this?
Yeah.
It's easy. So brown, red, orange, yellow, green, blue, violet, gray, gold, silver. Did you remember sequence?
Yeah.
Just BB Roy goes to if you want to write, you can write there in statement also. BB Roy goes to Bombay via gateway with gold and silver.
Yeah, sir. Just want let me take a screenshot.
Or you can write also like
I
BB.
don't have my notebook with me right now.
It's okay. Roy goes to Bombay via gateway. Gold and silver. Okay, now how to use this? That is second thing. Once you remember this, second thing how to use this. So just let me just give you introduction first, how to maintain these numbers. So first digit, next multiplier and tolerance. Everything that starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. Here nothing. Multiplier. So this is 10 to power 0, 10 to power 1, and so on till 10 to power 9. Here it is 0.1, means 10 to power minus 1, 0.01. So this goes on 10 to power 2, 10 to power 3, 10 to power 4, 10 to power 5, 10 to power 6, 10 to power 7, 10 to power 8. Now tolerance. There is no tolerance for this one, only gold and silver. Gold has 5%, silver has 10%. And one more is that is 20% for no color. Now you can take a screenshot of this. But no, wait. I'll draw it here also because that also need where is tolerance? What is it? No. This is first color, second color, third, fourth. Now this is first digit, first digit, second digit, third one is multiplier, fourth one is tolerance. Now suppose we have color sequence as red, yellow, green, silver. Now how to write this? Red. So first find out red. Where is red? Second number. So it is 2. Red. Red has 2. We change color.
2,
Red means 2.
4,
Yellow is 4. Yes, means 24. We got one number.
5.
Now
And
multiply. No, now 5 is multiplier. Third one is multiplier. Means green. Green. What is number for green? Here we have to see this one then. Means into 10 to power 5. This we got color coding of this one. Last one is silver. Silver is tolerance. Fourth, I said it is tolerance. Means silver 10%. That means we'll write here plus or minus 10%. This is the answer.
okay, so we'll get these type of questions in JEE.
Hmm.
Like we should
In-
find the value, or we should just write the sequence.
Exactly. But there is other way of also writing this one. Now, other same thing we will write in different way. Now 24 into 10 to power 5, I can write as 2.5 into 10 to power 6. 6 means mega. Now 2.5 into 10 to power, so 2.4 into 10 to power 6 plus 10% minus 10%. So 10% of 2.5 is what? 0.24. Am I right?
Yeah, sir.
So this one we can write as 2.5 plus or minus 0.24 mega ohm. I'm sorry, not 2.5, I'm writing 5 here. It's 4. Clear?
Yeah, sir.
You can take screenshot of this guy, color coding.
So can you also send us notes? Like
Yeah,
I haven't noted down anything much.
it's okay. I'll send it. Because this one I'm writing in notes only, so that can be shared easily. Previously, I was writing in like one note. I was not able to share. This type of question we'll do some more, but right now we'll continue our discussion.
Okay, sir.
So we'll take, while doing questions, I'll find out some good questions. Okay, so let's see temperature. And resistance. Now in this one, temperature, if temperature of conductor increase. Now when temperature of conductor increase, inside the like molecules are there or ions are there, their vibration also increase. Vibration of,
When the molecule's kinetic energy increases, the temperature increases.
exactly. So when ion vibration increase, What happened? What happened to relaxation time?
It decreases.
Exactly, because what is relaxation time? Time duration between them. So relaxation time decreases. Therefore, resistivity is what? M by NE square tau. So resistivity increases. And conductivity is 1 by rho, means it
It
increases.
decreases. Okay, yeah, it increases.
No, sorry, correct only, decreases only, because it's inverse.
Yeah. So conductivity is directly proportional to tau, and resistivity is inversely proportional to tau.
Exactly. So formula rho equals to rho naught 1 plus alpha delta t.
We had a similar formula last year also, right?
Yeah.
In
In 10th standard we
mechanics.
had. In 10th standard also we wrote. We didn't do anything, but and R is proportional to rho.
So it depends the same. Like the dependence
Exactly.
is the same.
Even length by area also changes, but it's negligible change. So R equals to rho 1 plus alpha delta t. Now let's recall that how to classify materials. What is conductors?
The
In
ones
terms,
that allow the flow of
no, not that way. In terms of electrons.
the ones which are free electrons.
Yeah, more number of free electrons.
Yeah, and very less nuclear charge.
Yes, and very less resistivity. So let's write some points for that, like chotu point. Conductor,
More number
large,
of free
free,
electrons and less resistance.
small, resistivity. Then what else we can write? Resistivity increases
So
with
temperature increases.
increase in temperature. Then next, let's write semiconductors. What about semiconductors? They have very few.
A very few amount of free electrons and moderate resistivity.
Hmm. So here, few electron, in the sense we'll say conduction electrons. Few conduction electrons. And it has greater resistivity.
Then conductors.
Yeah, as compared to metals or conductors. T with T as compared to metals. So resistivity decrease with increase in temperature. Resistivity decrease with increase in temperature. This thing you need to remember. Now, what about insulators?
Uh, there are no conducting electrons and
Exactly. Or we can say no conducting electrons, no free electrons, whatever.
very high resistivity
Very, very high.
and rho does not change with temperature. Like there's no effect of temperature.
No, it will behave as the same.
Okay, rho decreases with temperature.
So rho resistivity decreases with rise in temperature. For example, we can say mica, rubber, and here, for example, we can write here silicon, germanium, metals. There are so many. Next one is superconductor. So these are special type of conductors. In this one, resistivity becomes zero. Like suddenly, we can say suddenly becomes zero. Now, when it is like when temperature goes below critical. Temperature goes below critical temperature. So it's like almost 4.2 Kelvin, like very, very low. So above, what happens above critical temperature?
It has resistance.
Yeah, it
Resistance.
behaves as a metal. They are metal. Below
Okay.
critical temperature, they are superconductor.
And when the temperature goes down, they don't act like conductors.
They will become superconductor actually, not just metal wala. Let me draw and show a graph. This is for normal.
Below critical point, they have zero resistance, right? So they are better conductors compared to conductors.
Yeah, like this. This is resistivity. This is temperature. So this is your critical temperature. This is resistivity. This is your normal.
Increases.
Yeah, normal metal. So this point suddenly they are increasing. This is
Superconductor.
superconductor. This point is called critical temperature. Now, what is the purpose of this one? For making work super magnet. Purpose is super magnet. You can make a super strong magnet or a transmission line. Transmission line means power transmission.
Okay.
Power, all that. Because there we required very low resistance. If it is more resistance, then it will be more power loss.
We basically use it for industrial purpose where we need
Yeah,
to reduce the loss of energy.
exactly. So here power transmission when we are using it is almost 125 Kelvin temperature. So it is low actually, even lower than our bulb. That's why if we touch also we will not like, but power is going so much, so it's heavy. But from far we won't get shock. That's why in the railway line also they have mentioned warning, stay away, 24,000 voltage, like that. So this all notes I'll share it to you by evening.
Okay, sir.
because now I'll go for office. Find this one. Yeah. So next class we'll do numericals based on this one.
Yes, can we also do more numericals in color code because like, we have never done that yet.
Yeah. That is easy. We'll do it. ठीक है बच्चे.
So do we
We'll
have a
stop
test tomorrow? Because like
test.
I won't be able to attend the test because like I'll be going outside the entire day. Like we're traveling. So is it fine if we conduct it on Monday or something?
Yeah, sure.
Thank you, sir.
Yep. Bye-bye.